students. This is the last week of class before final exams. Today is April the 25th, Saturday. So, to make a long story short, this week we are going to cover the Cenozoic era. The Cenozoic era began 65 million years ago. And it's important to remember that the Mesozoic era ended 65 million years ago. You might recall that a large meteorite had struck the planet 65 million years ago, wiping out the dinosaurs, wiping out the pterosaurs, wiping out marine reptiles such as plesiosaurs, mesosaurs, ichthyosaurs, and many smaller forms of life were also wiped out, such as many types of foraminifera. If you watch that video about the extinction of the dinosaurs 65 million years ago, you want to remember that the idea that the dinosaurs were wiped out instantaneously 65 million years ago came from an American geologist by the name of Walter Alvarez. And you want to remember why. What evidence do we have that the dinosaurs died out 65 million years ago? Make a list of all of the data that supports that hypothesis. And 65 million years ago began the Cenozoic era. And here's the title page of chapter 16. Cenozoic Earth History, the Paleogene and Neogene periods. A lot of people use that terminology, Paleogene and Neogene, as you can see here on this chart, to represent 65 million years ago to 2.5 million years ago. And then the last 2.5 million years is called the Quaternary. We're living in the Quaternary period today. However, most American geologists use this other word, which you're going to see again and again and again, called Tertiary. The Tertiary period is what we're going to use instead of Paleogene and Neogene. It'll also make it easier for you to remember on the test. The Tertiary period, so instead of using Paleogene and Neogene, we're going to combine those together and call that the Tertiary. The Tertiary period began 65 million years ago and ended 2.5 million years ago. So there's two periods that you need to remember for the Cenozoic. Tertiary, from 65 million years ago to 2.5 million years ago, and Quaternary, from 2.5 million years ago till today. During the first several weeks of class, we talked about the geologic time scale. I think you're probably a lot more comfortable with it now. We talked about there being eons, the largest subdivision of geologic time. And we talked about how eons break down into eras. Then we talked about how eras break down into periods. And then we talked about how periods break down into epochs. That's what these are here. We've never talked about epochs before. They're the smallest subdivision of geologic time. Here you can see, for example, the epochs of the Cenozoic era. Paleocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene, Holocene. We're living the Holocene epoch right now, which began about 11,700 years ago. What happened 11,700 years ago, you might ask? That's when the Ice Age ended. So the Ice Age, scientists call the Ice Age the Pleistocene. The Pleistocene. The Pleistocene began 2.5 million years ago, and it ended 11,700 years ago. Our ancestors, everybody, all of you sitting in your living rooms, people all around the world, their ancestry can be traced back to our ancient Ice Age ancestors. And we're going to talk about what it was like for our ancestors, Homo sapiens, to have lived during the Ice Age. It was a much more dangerous world then. There were saber-toothed cats, cave bears, dire wolves, and many other enemies. And there were other types of humans who lived amongst us. They're called the Neanderthals. We'll talk about that later. But first, we're going to talk about the geology of the Cenozoic. We're going to focus mainly on our own country, the United States, but we're also going to talk about the rest of the world. Here you can see what the world looked like during this. Don't be fooled by this. When you see this picture here, this is for the Mesozoic. And why are they showing you a picture of the world during the Mesozoic in a chapter that's titled the Cenozoic? Well, they put it here so you could compare it to the next set of the next map of the world. So this here is the map of the world during the end of the Mesozoic, during the Cretaceous period. First, let's take a look at it before we move on forwards to the Cenozoic era. At the end of the Mesozoic, you can see that Gondwana has broken up into South America, Africa, India, Australia, and Antarctica. You can also see that Laurasia has broken up so that we have formed North America over here. Here's the Cretaceous Interior Seaway. Greenland had formed. And then here you can see Eurasia. Bottom line is, by the end of the Mesozoic, the world is starting to look more familiar to us. Still, it looks much different. The Atlantic Ocean is not as wide. India, pay special attention to India. India is an island all the way down here in the southern hemisphere. Australia had just broken off of Antarctica, by the way. But here's India here. We want to pay special attention to India because something's going to happen with India. Now let's take a look at the world during the Cenozoic. This is during the Eocene. That means during the middle part of the Cenozoic era. Notice that the Atlantic Ocean continues to widen. We start to form the Mid-Atlantic Ridge. This divergent plate boundary is so that North America moves farther and farther away from Greenland and Europe. South America moves farther away from Africa, so that the North Atlantic starts to widen. The South Atlantic starts to widen. But what has happened to India? India used to be down here during the Cenozoic, all the way down here in the southern hemisphere. What has happened to it? Have you noticed that it has moved north, closer and closer to Eurasia? It hasn't collided with Eurasia, but it's getting very close. What will happen when India collides with Eurasia? You want to think about this. Well, okay. Anyway, the North Atlantic has moved away. Europe. This is starting. This is later on during the Cenozoic. You can see the South Atlantic has continued to widen, the North Atlantic has widened, everything is getting closer, so that by this time you can see India here towards the end of the Cenozoic has collided with Eurasia. India has collided with Eurasia to form the what mountains? Begins with the letter H. The Himalayan Mountains. The Himalayan Mountains were formed about 8 million years ago to 10 million years ago. India collided with Eurasia, pushing up the Himalayan Mountains. So India was sutured together to Eurasia at this continental convergent plate boundary. Bottom line is, during the Cenozoic era, the main things that happened were the Atlantic Ocean widened, India collided with Eurasia, Australia broke away from Antarctica. That is what you want to remember for the Cenozoic era. And what is this picture here showing you? Well, this is showing you, it says Cenozoic orogenic belts. You might recall that orogenic means mountain, so we could say Cenozoic mountain belts if you'd like. And these mountain belts are shown here. The orange is shields. That's where Precambrian rocks are exposed, but we're not talking about that. We're talking about mountain belts. Mountain belts form in all of these different areas here that you see here in red, for example. We have the Alpine Himalayan belt. But bottom line, without going into all the details of this map, the plate tectonic map that you studied back in the plate tectonics chapter has been formed by the end of the Cenozoic era. So we have our mid-ocean ridge systems, we have our subduction off of our west coast, subduction off the coast of South America, subduction here in the Mediterranean. Please don't forget that the Alps of southern Europe, were formed during the Cenozoic era. How did the Alps form? The Alps formed from Africa pushing into Europe, forming a subduction zone here in the Mediterranean, pushing up the Alps. See the folds in the Alps? Those are synclines and anticlines. They're folded mountains that were formed by Africa pushing into Europe during the Cenozoic era. Don't forget about India. Here's India 71 million years ago. It moves north to here about 55 million years ago. Finally, it collides with Eurasia about 8 to 10 million years ago, pushing up the Himalayan mountains. The Himalayan mountains are the youngest mountain range in the world. Therefore, they are the tallest mountains in the world. Okay, so India, don't forget about India, Cenozoic in age. Appalachians, Paleozoic in age. The Rocky Mountains, Mesozoic in age. This is the beautiful Himalayan mountains, formed by India pushing into Eurasia, starting about 8 million years ago. This shows you all of the land that was added onto the western edge or the western margin of North America during the Mesozoic and Cenozoic. And what the author is trying to convey to you is that all of the western states of the United States, all of the western provinces of Mexico, all of the western provinces of Canada were added on to North America during the Mesozoic and Cenozoic era. Why? Because we had subduction occurring off the coast of western North America from the Mesozoic to the Cenozoic. Our mountain building, where did it occur? During the Mesozoic and Cenozoic, it occurred on our west coast. You might recall that during the Paleozoic, subduction occurred on the east coast, forming the Appalachian Mountains. which are much older. They are Paleozoic in age. So the Appalachians are an ancient mountain range, 290 million years old, formed during the Paleozoic. The Rocky Mountains were added during the Mesozoic. And now we're going to see what was it. More and more land keeps getting added onto the western margin, the western edge of North America during the Cenozoic, including the Cascades and the Sierra Nevadas and the Colorado Plateau, which we're going to take a look at soon, today. This shows you subduction. You might recall subduction. Subduction causes mountain ranges to form and adds new land to the edges of continents. So subduction occurred on our west coast during the Mesozoic and Cenozoic eras, adding on new land, including the Rocky Mountains during the Mesozoic and the Cascades, the Colorado Plateau, and the Sierra Nevadas during the Cenozoic era. Here you can see all of these volcanic rocks in color here. And these are formed by subduction occurring along our west coast during the Cenozoic era. So we had lots of volcanism going all the way here from Washington, Oregon, California, Nevada to Arizona to New Mexico, Colorado, even into Wyoming, all due to the subduction occurring off of our west coast during the Cenozoic era. When you go out west, you can see these volcanic rocks in places like Washington and Idaho. Oregon and Arizona. What kind of volcanic rocks? Well, they're called rhyolites and andesites. Another thing that you want to remember that formed during the Cenozoic era was the Cascade Ranges. The Cascade Range. What is the Cascade Range? Well, if you're from the West Coast, you know what the Cascade Range is. And since most of you are not from the West Coast, let me show you where it is. The Cascade Ranges are shown here. They start here in Northern California with Mount Lassen. Then they go to Mount Shasta, Crater Lake, Mount Hood, Mount Adams, Mount St. Helens, which is famous for erupting in 1980, Mount Rainier, and Mount Baker, and all the way up here, they didn't show it, Mount Garibaldi near Vancouver. So they go from Northern California to the southern part of British Columbia, which is a province of Canada. This is called the Cascade Mountain Range. And this mountain range formed from subduction over here of oceanic lithosphere underneath the Pacific Northwest, forming this mountain range that was formed during the Cenozoic era. And it's called the Cascade Mountain Range. The Cascades, formed during the Cenozoic era. Another feature that is formed during the Cenozoic era is the Basin and Range Province. Again, another thing that people are very familiar with out west. Take a look and we'll see where it is. This, ladies and gentlemen, is the Basin and Range Province, going all the way into Mexico, Arizona, Nevada, Salt Lake City. This whole area is called the Basin and Range Province. And it was added on. This whole area was added on to the western edge of North America during the Cenozoic era, the Basin and Range Province. So was this. The Colorado Plateau was added on. But basically, during the Cenozoic era, more land was added to the western edge of North America. The Sierra Nevadas. What in God's name are the Sierra Nevadas? Well, every Californian knows this, but since most of you are grew up west of the east of the Mississippi, you're probably not as familiar with it. It's a mountain range that exists in eastern California. When people think of California, they think of the big cities: San Diego, Los Angeles, San Francisco, Sacramento. But there is a huge mountain range in eastern California, which is very sparsely populated. This whole area is called the Sierra Nevadas in eastern California, added onto the edges of the North American continent during the Cenozoic era. Beautiful mountains here you can see in eastern California. The Colorado Plateau, also added to the edge of the margins of the North American continent during the Cenozoic era. Colorado Plateau includes some of the most beautiful scenery we can see in North America, including the Grand Canyon, Bryce Canyon National Park, Zion National Park. This is all of that land that was pushed up in Colorado, Utah, Arizona, and New Mexico. Don't forget the Colorado Plateau area, centered around the great state of Colorado, was added on to the western margins of North America. Now, all of these geologic features that we talked about here in chapter 16 occurred due to subduction occurring off of our west coast. And this subduction began during the Mesozoic era, added on the Rocky Mountains during the Mesozoic. And in order to understand how this works, we have to think back to plate tectonics and how it works. And if you take a look at these three pictures here showing the western edge of North America during the Cenozoic era, you can see what caused all of these features to form. The Colorado Plateau, the Sierra Nevadas, the Cascade Mountain Range, was all formed by subduction. So here you can see up here in the upper left of these maps the age. So this is 40 million years ago, this is 20 million years ago, and this is today. Let's see what happened in terms of plate tectonics from 40 million years ago during earlier part of the Cenozoic to 20 million years ago to today. Here you can see wherever you see these black triangles, that's subduction. So we had a subduction zone occurring down the entire length of the west coast, going all the way from Alaska and the Aleutian Islands down the west coast of Canada, west coast of North America to the west coast of Mexico. And this subduction created a lot of those features like the Sierra Nevadas and the Colorado Plateau, Cascades. Here you see a mid-ocean ridge. Look how close to this. This is a divergent plate boundary. Notice how the arrows are coming apart. This plate here is called the Farallon Plate. This is the Pacific Plate. Notice that this mid-ocean ridge system is getting real close to the continent. Eventually it collides with the continent, and we go to here and you can see that we still have this tiny little bit of plate here. It used to be much bigger over here. And this plate here is called the Juan de Fuca Plate. The Juan de Fuca Plate subducts off of the coast of western Canada, Oregon, Washington, and northern California, producing the Cascade Mountains. Over here you can see another tiny plate here subducting off of Mexico. And here you have the San Andreas Fault. So you got a subduction here, here, and over here you got a transform plate boundary. This is how, but the main thing you want to remember is that subduction occurs off the west coast of North America from the Mesozoic to the Cenozoic, and the Cascade Mountains here forms exist because of this subduction zone, because of the Juan de Fuca plate subducting underneath North America. And over here, the Cocos plate subducts underneath Mexico, going all the way to Costa Rica. That's for you, Giocondo. Cocos plate subducts underneath South America. I mean, not South America, Central America, producing volcanoes in the Costa Rica area, going all the way into Mexico. Okay, that's it, ladies and gentlemen, for chapter 16. I'm going to put up a couple more videos for you, but I'm going to stop this one here.